Explain like I'm 5. How do the odds of flipping a coin work? I know. 50-50 heads tails, right? But help me understand the next step. Each coin flip has a 50-50 shot of heads or tails. What I don't understand is how the likelihood of the next flip doesn't change. For example, if I flipped a coin 10 times and every time it flipped heads, the next flip would be 50-50 tails. Wouldn't the likelihood of flipping a coin 11 times and having it be heads every time be really low? 0.511, 0.048. Here's the origin of the question. I was at a roulette table and the guy said it's been black the last 8 rolls. The next one has to be red. At first I thought, the next roll will be 47 black, 47 red, 60 or 00, you fucking imbecile. Then I thought to myself, what are the chances that there are no red rolls in 9 rolls? Which is well below 1. Am I the imbecile? The coin has no memory. The odds of flipping 11 heads in a row is 0.048. But the odds of flipping 11 heads in a row, given that you already flipped 10 heads, is back to 50-50. The chance of flipping 11 heads in a row is 0.048. The chance of flipping 10 heads in a row, and then a tail, is also 0.048. You are talking about the probability of a single event versus a series of events. The probability of 20 heads in a row is 0.5, but then you're asking about just the next flip. It's still 50-50. If that 21st flip is tails, you would have a pattern of 20 heads and then 1 tails. The probability of those exact 21 flips is 0.5. It helps to remember that the odds of a spin ending up with 8 black and 1 red, or 9 black and 0 red, sequentially is the same. The individual odds of each flip is always 50-50. It always is that way. Those are just your 2 options. Now the odds do change when you talk about stringing multiple flips together. For example, let's say you flip the coin twice. The odds of getting 2 heads are 1/4 or 25. For each individual flip it is still 50-50. But to get that specific whole string of flips it is 25, because you could get heads heads, heads tails, tails heads, tails tails. There are 4 possible outcomes for a 2-flip string, meaning each outcome has a 25 chance of happening. If you were to go by the logic that previous flips matter, why wouldn't coin flips you made 1 year ago or coin flips made in another country not also matter? There are many sequences you can flip a coin in and they all have equally likely chances. Tails or heads 3 times in a row stand out more, but we don't bat an eye to mixed sequences like HT, T or THT, of which there are more than perfect ones. The likelihood of flipping heads 11 times in a row is small. But every other sequence is also unique, even though it seems more random. The odds of any specific sequence is the same. 10 straight heads, 10 straight tails. First 5 heads, last 5 tails are all equiprobable. Also, we assume the events are independent. The coin isn't affected by the previous flips. You are not the imbecile. Those tiny chances that it happened 11 straight times are dependent on specific outcomes over the course of 11 instances. Each individual flip of a coin is 50-50. And that should be particularly apparent. Another way to think about it is that if you land heads 10 times straight, then the odds that you'll land heads 11 times straight are right now 50-50. The hard part of the math has already happened. The odds of getting 10 tails then 1 head are the same as getting 10 tails and then another tail. Both series are equally unlikely but OFC possible. So the odds of that last event are 50-50. Getting head on the 11th toss after getting heads in all previous 10 tosses is not same as getting heads 11 times in a row. The former experiment has already established that 10 heads in row have been observed, which in itself is an astronomically rare event, and getting head in the next toss is always 50-50. If you consider the chances of getting 10 heads in a row in the first place, then you get the same chances as the latter case. The coin doesn't have a memory of how it landed last time. So whatever the recent history was, it still has a 50 chance of landing on either side. It is unlikely it will land on heads 9 times in a row. So if you predict 9 heads in a row before any tosses are made, you will pretty certainly be wrong. But if you do by chance get 8 heads in a row, and then predict heads on the next toss, you have a 50 chance of being right, because the coin doesn't know that it already landed on heads 8 times. The usual model would say that 8 blacks in roulette do not change the probabilities on the next roll. Likewise with coin tossing. For example, in 2 coin tosses, with the usual model, the following outcomes have equal probability: HH, HT, TH, TT. Getting a heads does not change the probability of getting heads on the next toss. Whether or not the standard models do a proper job of modeling reality is another question. Something that helped me with thinking about this is that every configuration has very low odds. TTTTTTTTTT has odds of 1/1024. HHHHHHHHHH has odds of 1/1024. So do THHTHHTHTT, HTTTHTHTTH, TTTTHTHHHH. The disconnect comes from us seeing HHHHHHHHHH as a special result, and HTHTTHHHTT as unremarkable, when they're both equally unlikely. 50-50 just means that half the tries are being one result. But of how many tries? It can be 5 of 10, 500 of 1000, or even 500 meters of 1B. X 200B. There was once a case in 1913 in the Monte Carlo casino. There was a roulette game going on with the ball falling 26 times in a row on black, even though the chances are 50. You're not incorrect. But you're not comparing apples to apples either. The odds of 10 heads and 1 tails is the exact same as the odds for 11 tails. Both of them have a 0.5 times 10 to the 11 chance. Real talk: if a real-world coin comes up heads 10 times in a row, it's almost certainly a coin with 2 heads or other such unfair coin. You should bet that it will come up heads on the 11th throw. Half the time you flip 10 heads in a row, the 11th flip will be tails, and half the time it'll be heads. It's 50-50. It's just very unlikely to happen. But half the times it happens, it will continue your streak. Did you check that it's not a 2-headed coin? Seriously. Though, all the other answers are assuming that the coin is known to be a fair one. The fact that it has just landed 10 straight heads, in my view, calls this assumption into question. Biased coins do exist in the real world. Granted, this is a physics issue more than a mathematics one. Fun fact: the probability of 20 tails straight is exactly the same of 10 tails followed by 10 heads, which is exactly the same of tailhead, and so on. Each of those outcomes is exactly 0.520.